Using dimensionality reduction in student performance analysis. Good day, everyone. This presentation shows how dimensionality reduction can help analyze student performance data more easily and effectively. Student data is usually large and complex. Data mining helps analyze this data. Dimensionality reduction simplifies the data while keeping important information. Schools find it difficult to predict student performance early. Too many data features cause repeated and inefficient information. This makes analysis slower and less accurate. The objectives of this study are to analyze student performance, apply dimensionality reduction, and predict student grades. The goal is to help educators make better decisions. This study helps identify students who are at risk of failing. It also supports better curriculum planning. Most importantly, it allows data-driven decision-making. The data set contains 5,000 student records. It includes academic, behavioral, and socioeconomic data. Some values are missing, and some features are highly related. First, missing values are handled. Next, text data is converted into numbers. Then, numeric values are normalized, and PCA is applied. The system starts with the input data set. The data is preprocessed, then reduced using PCA. After that, classification and clustering are performed to generate insights. PCA reduces the number of features in the dataset. It keeps the most important information. This makes analysis faster and easier to understand. The system is implemented using Python. Libraries such as Pandas and scikit-learn are used. PCA, decision tree, and k-means algorithms are applied. The classification accuracy is about 25%. Clustering helps identify groups of students based on performance. These results show that dimensionality reduction is effective. Libraries import pandas as PD import numpy as NP used for data handling and numerical operations. From sklearn.model selection, import train test, chat split from sklearn.tree import. Decision tree classifier from sklearn.metrics, import accuracy, score used for splitting data, training a classifier, and evaluating accuracy. From sklearn cluster import, k-means from sklearn, decomposition import, PCA from sklearn, preprocessing import, standard scalar. PCA, dimensionality reduction, k-means, clustering, standard scalar, feature normalization import, matplotlib.pyplot as PLT used for plotting graphs. Dataset data equals pd.read csv.students underscore grading underscore dataset.csv reads the CSV file into a data frame. Print fshape data.shape displays number of rows and columns. Features equals open bracket age comma. Attendance percent open bracket close bracket comma. Midterm underscore score comma. Final underscore score comma. Assignments underscore AVG comma. Quizzes underscore AVG comma. Participation underscore score comma. Projects underscore score comma. Study underscore hours underscore per underscore. Week comma. Stress underscore level open bracket 1 to 10. Close bracket. Selects numerical columns that influence student performance. X equals data. Open square brackets, features close square brackets. Filna, open, parenthesis. Data open, square brackets. Features close square brackets. Mean, close parenthesis. Replaces missing values with the mean of each feature. Y equals data. Open square brackets. Grade, close square brackets. Target variable, open parenthesis. Labels for classification, close parenthesis. Scaling scalar equals standard scalar, x scaled equals scalar dot. Fit, transform x, converts all features to the same scale, prevents features with large values from dominating the model PCA, dimensionality reduction. PCA equals PCA n components equals 2. XU PCA equals PCA dot fit. Transform XU scaled. Reduces 10 features to 2 principal components. Keeps maximum variance. Information, PCA.explained variance, a tried ratio. Art shows how much information each principal component retains. PCA visualization by grade for grade, insorted YB pi did unique. Mask, IB grade, separates students by grade, A, B, C, etc. Axes, scatter X PCA mask, 0, 0, X PK mask, 1. Plots students in 2D PCA space. Purpose, visually check if grades form natural patterns. K means clustering K means equals, KE means open parenthesis. N underscore clusters equals 3. Random state equals 42 close parenthesis clusters. Equals K-means dot fit, predict open parenthesis. X underscore PCA close parenthesis. Groups students into 3 clusters based on similarity. K-means dot cluster centers shows the center of each cluster. Purpose, finds patterns without using grades. Unsupervised learning. PLT dot savefig, PCA underscore results, dot PNG, DPI equals 300. Saves the PCA and clustering visualization as an image file. Decision tree classification, original data. X-train, X-test, Y-train, Y-test equals train test split. X, Y, test size equals 0.2 splits. Data into 80% training and 20% testing. CLF-autorig equals decision tree classifier. CLF-autorig.fit. X-train Y-train trains a decision tree using original features. ACC-autorig equals accuracy, score. Y-test CLF-autorig.predict. X-test calculates prediction, accuracy. X-train to PCA, X-test PCA, Y-train to PCA, Y-test PCA, got train to test its split. X to PCA, Y, uses only 2 PCA components instead of 10 features. CLF PCA fit, X train to PCA, Y train to PCA, on trains classifier on reduced data. Purpose, compare performance, before versus after PCA, icon E. Summary print. Reduced X.shape8 font features, 2 components. Shows feature reduction. Print file retained, shown some PCA.explained, variance for named ratio, 100.1% variance. Shows how much information remains after PCA. Print F accuracy, po 100.9%. PCA reduced the data from 10 features to 2. This made the data easier to visualize, but most important information was lost. Because of that, grades overlap in the graph. Clusters do not match grades. Prediction accuracy dropped from 33.2% to 22.4%. In one sentence, PCA helped us see the data, but it was not good for predicting grades because too much information was removed.